I know you're probably looking forward to another video by me, but this is just an extra video, kind of putting a lot of things into one video for people who are beginning out in their early experiences with R. So probably the biggest problem for people starting out is, how do I get the data into R? Well, okay, so let's say that you just have some numbers that you want to enter, that you just have them and you're going to enter them directly into R. So you just come up with a variable name. That'll be something really creative there and call it X. And then put C, open and close parentheses. C stands for combine or concatenate. And then just within those parentheses, just put a bunch of numbers. And I'm just making these up, of course. And separate the numbers by commas. And let me get rid of this stuff down here. That's from something else I was working on. And by the way, I've switched the order of the windows in here through tools and global options. I did that for my class this week because a lot of the room's pretty big and some people at the back. I'm going to put this up at the top so maybe they don't have to stand up to see what's going on at the bottom there. But you can arrange the windows however you want. But anyway, I'm going to click Run now, and you can see that a few things happened. Now, the source and the console, if you're just working plain R, you would just work through the console. By working in the source here, I can go up and make a change pretty easily up here, and plus I can have a bunch of code and I can just save all of it for the next time I want to work. So I always work through the source window rather than the console, but when you run it, it's going to put it in the console too. And then this global environment, here it just says that we have a variable X and that it's numerical, and there's 9 of them, 1 to 9, and there's a list of them. Of course, if there were 900 of them, it wouldn't list all of them right there, but since there aren't that many, it lists them there for you. Then once I have that, I can do mean of X and standard deviation of X, which is just SD, run. And I can do something like boxplot X and run. And you can see it puts that up in the graphing window. By the way, if you wanted to put this plot into a document, probably the easiest way is to export, copy to clipboard, and copy plot. Then you can just Control-V or right-click and paste, however you would normally do that, into a Word document or whatever word processor you're using. So if I'm going to do some other stuff here, and I don't have to do what I'm going to do now, but I just want to clear everything out to have a clean working space here. So the broom here, we'll get rid of all of the plots there. A broom here, we'll get rid of everything out of there. Especially if you work with a lot of data sets, you're going to want to do that from time to time too. Just to get everything starting off in a clear way. But in the console, you can do Control-L. That's an old R command, not RStudio, but that'll just clear out the console for you. And I'm just going to highlight that and hit delete to get rid of that stuff. Okay, so the next thing is another way to get data in is if you have it saved in some kind of file. The way I do mine is I get them in Excel, whatever I need to do there. And then I save that as a CSV file. So just go and File, Save As, and then get the CSV extension there. There's 2 or 3 of them. Just get the one that's plain CSV. So I have a file. It's called Goals. It's on my desktop. And I want to read that into R. So I'm going to give a name to the whole data set. I'm going to call it my data. And I'm going to put read.csv because I'm reading a file that I've saved in CSV format. And I'm going to open and close parentheses and quotation marks. And in there, I'm going to type the name of the data set, which was goals with no caps or anything. And then you have to give it the file extension. And then click Run. And there that is. Now, I'd already done something that I need to show you here. My file is on my desktop, and so before I did what I just did there, I had to set the working directory to, and just, wherever I was. If I were here, just go to your desktop, and it says desktop there, and select that folder. Again, that was session, set working directory, choose directory, and then once you've done that, just explore or go until you get to the directory where your data are located. And then you don't always have to do the next thing I'm going to do, but certainly at the spot where you guys are at, this will save you some, well, I think, time and maybe a little aggravation here as well. So I'm going to attach my data. If you don't do this, every time you refer to a variable, and it's a little inconsistent this, but you might have to put my data $ name of the variable. And I don't type that quickly, so I don't want to do that every time. So I just attach the data set. And now that data set is in the working memory, and everything I do from here on out will assume that I'm using this data set. So I want to get the names of my data. I remember what they are in this data set because there aren't that many of them, but if you have something with 100 names in it, sometimes you forget. In fact, anyway, there they are. A lot of times what I do, that is one of the commands I will type down here a lot because I don't really need to keep it, but if I'm working down something and I've got a couple of 100 lines, then I'm just going to go there and hit enter, and that'll do the same thing. I'm going to click back up here now. So now that's in. I can put mean number, and now note that in the data set, and by looking at the names, you can see I have capital N number, and then just click run. And there's the mean, and I can do a box plot. And there we go with that. Okay, so now I think maybe a good thing for me to do is go back through the stuff where I want to get the mean for each group. Remember, goal was just type of goal that people had, and the number was the number of items they listed. So I can do, and there's more than one command for this. The one that I like is called Twoply. It's just the output is a little bit neater. And then you put the name of the quantitative variable for which you're computing the mean or whatever other statistic you're computing. And then the group, or the name of the group, and this I put group, I put the group. In this case, it's goal, the categorical variable. In this case, I have 3 types of goals. And then you put the name of the statistic or that you want to compute for each of those. And I always start with length. That gets me the sample size. And you can say I had 75 per group. And then I'm just going to do Control-C and Control-C and Control-V. Get them in here. I'm just going to change length to mean. Run that line. And there's the mean for each group, and you can see that the group that had the challenging goals was 11. It was the highest. And then the attainable was 9. Not quite at 10, but they were getting close to the goal of 10 that you set. If you just got a vague goal, performance wasn't all that impressive at all. And then I'm going to get the standard deviation. And you can see that the standard deviation was really high with the challenging group and pretty high with the vague. And then the least variable was the attainable. In other words, everybody, maybe they didn't get 10, but they got close to 10. It was an attainable goal for those who wanted to meet it. Challenging, I think what happens is some people get up to that one was list 20, which in 5 minutes is pretty hard to do. Well, some people really got after it and got up to 16, 18, or 20, and some people, I think, probably about 20 seconds in said 20, I'm not going to be able to get that, and so they just give up and maybe list 1 or 2 ideas. That's why you have such a high standard deviation there. Okay, so to go with this, you're going to want to have some kind of graphs that show the differences in the groups. And the box plot's a pretty good one for that. And so now I'm going to put number and goal. So it's a tilde there. Just says give me a box plot for number by the type of goal that they had there. And there you can see I have a box plot. And again, you can see challenging is the highest, and also the most variable of the two. And then attainable is the next highest, and then vague is the lowest, just like what we said when we looked at the means and the standard deviations. The other kind of graph I use a lot when I'm comparing 2 or 3 or more groups for a quantitative variable is a density plot. You can do histograms in R. If you do, you kind of have to put them in different windows, which we could do that. I'm not going to do that in this video. And you can use something else, and there is a graphing package within R that you can do that actually does a pretty cool density plot where but that's beyond where we're going to go right now. The thing that I do use quite a bit, and I kind of like it, is a density plot. It's a histogram where, sort of, except for it really doesn't have bends, and it's just a smooth curve of where you would think the data are. There's a little bit more to it than that, but it does give you a good sense of the shape of the data and set and where things are at. So the density plot that I'm going to use is not the default density plot for this when you want to look at it by group. It's in a package called SM. And so if you haven't already done this, then you'll have to go to your window that has the packages on it and just click Install and SM. It'll come up, and just click on it and click Install. Now I already have it installed, so I'm not going to reinstall it, but make sure you have this check install dependencies there. That way, if there's another package that SM needs in order to work, it'll install that too. And once you've installed that on your computer, you'll never have to install it again. And you can see in my list here of programs, I already have more than you probably have on yours, because I have quite a few packages on here, but there it is. You do have to, it's installed, but it's not in working memory. There are a lot of default programs that are in working memory, but this isn't one of them. So I'm going to have to say require SM. That's going to put it into the working space here. And so that package is there. And the command is SM density dot compare. Can't believe I memorized that, but I guess I finally did. And then you put number, and it's a comma in this one, not a tilde, goal. And there you have it. And you can see that there's one group with a lot of variability and a higher. That's the people in the challenging group. And then you can see the next highest, and that's going to be the attainable, and then the vague goals here. Now, a lot of what I'm going to do after this on this video is just look at these box plots and this density plot and make them look a little bit better and more independent, and have all the information there where you can find it. For example, at some point I'm going to want to put a title on the graph, and I'm going to want to write on here that in some way that this red one is the attainable group, and that the one here, the green dash, is the challenging group, and so on. So someone can just look at this and not have to work very hard to figure out what's on your graph. Okay, so what I'm going to do is take this box plot, and I'm just going to copy that right down here. I'm going to give me a lot of space here so you can see things better. And okay, so I'm going to run that. I'm going to copy that again, and I'm just going to do one thing at a time here. And I actually kind of recommend that while you're starting out, that you only do one, at most 2 things at a time, and then just work your way through, kind of like what I'm going to do right here. That way, if you do make a mistake or an error somewhere, you can catch it immediately. So I don't like the box around the graph. So frame dot plot equal false. We'll get rid of that. And you can see that's gone. Now I'm going to take that and copy it. And I'm going to do one more thing. How about I'm going to put some colors in those plots. So I'm going to put a comma. And what I do is I put enter right then. I always put a comma at the end of the line here. So I make sure I have it. And then the next thing I want to do is I'm going to say color, which is COL, equal. Now I could do this. I can just put coral. That's a color. And you'll see now that all of the plots are colored coral. But I really would kind of like to have a different color for each plot. So now what I'm going to do is, first I'm going to color equal C, open and close parentheses. I'm going to combine things again. I'm going to put that color inside quotation marks, comma, inside quotation marks another color. I'm going to try forest green. Arrow over to get outside of that, and then another set of quotation marks. And it's baseball season, and even though the Dodgers aren't my favorite team, I'll go with Dodger blue. And now I have a graph with colors for each graph. So I'm going to copy all of that now. You wouldn't necessarily want to copy this every time if you were doing it on your own. I'm just doing this so we have a record of where I've been. You can see each step as we go through here. And so I'm going to put a comma here and then enter down. And I'm going to give this, I think what I like to do is change the width of the boxes. It looks a little wide for me. I think it'll look better if it's a little narrower than that. And so that's box wex equal, and I'm going to put 0.5. I usually use something around 0.5 or 0.4, but again, that's a personal preference. That's how I like them. And then let's see here. I'm going to copy all of that. And I think now I would like to change the orientation of the boxes. I'm going to go horizontal instead of vertical. So I'm going to put horizontal. The default is vertical. Horizontal equal true. Now again, to be honest with you, and I'm not liking that look up there, but we can get to that in a minute here. Think about what kind of things we might do. And so now the next thing I'm going to do is put in a title. And that's main equal, and then parentheses here, I'm going to put number listed by goal type. Whatever your title is, it's going to have to be in quotation marks. And there was something else I think I'm going to leave off of this one. I'm not going to do changing margins or anything. And since this isn't coming out the way I wanted, I think I'm going to just get rid of the horizontal thing on here. And there we have that. A couple things here just to show you while I have this here. Copy it again. You see how that 5, 10, and 15 is oriented this way? There's a command that's called LAS. I'm not sure what that stands for, but I know if you set it to 1, or I'm pretty sure if you set it to 1, if I'm wrong, then I'll change it to another number. Okay, I left that horizontal thing in there. I don't want to do that. And the reason is you can see how they don't show it pushes the names off. I can change the margins and and push that all over, but I think that's probably a little bit much in a from where we're at right now. If this is your early on in your R experience, so there we go. It did change that 5, 10, and 15 to the normal way you would read things. And let's say that on that title, that I wanted that title on 2 lines. Go in this. I'm going to start with the word Y. If you do boxplot in, that says go to the next line. Don't put a space there. And this isn't something you actually need to do, but just so you can see how things go. Okay, one other thing on the box plots I'll do here. Let's just say I want to add some text onto the plot. Let's say, for example, that over here at the veg that I want to write the word outliers over here or off to the right-hand side or somewhere to this. Now, this is when you do this, you've already got the box plot. The next thing is going to be something that you're just going to say text. And then you have to give it numbers for the X and the Y axis. Now in box plots, when you have 3 of them, it's the center here is 1, the center of the next one is 2, the center of the next one is 3, and so on. So I'm going to put 3, and since I want it to go a little bit off to the right, I'm going to put 3.2. And you just have to experiment with this kind of thing. So I'm going to put X as 3.2. And then I'm going to say, let's see, that's at about maybe 7.5. I'm just reading that. That's just a Y value off of this axis. And then in quotations, I'm going to put the word that I want to have there, outlier. Now, 90% of the time, I miss this on exactly where it's at. Then I have to go back and just change the X and the Y values until I get it where I want it. Yeah, see, like that one, I did okay on the Y value, but it doesn't look like that 3.2. I think I'm going to go out to 3. Let's go. I'm going to try 3 and just get a little bit further away there to make it a little more readable. That's okay, but I might now, seeing how far that drug that out of there, I might put that 3.25. And that's how you have to do that when you're putting text on there, just kind of trial and error. At least my eyes aren't good enough to do better than that. Okay, so there's just some ways to get your comparative box plot and do some options to make it look like you want it to look. And of course you can, I think this makes it easy to see some things like now I could label that in other places too, outlier in that, and I can actually put some other things on here, but it's pretty easy to see that the challenging has the highest, the lowest is with the vague, although they had some outliers there, and that the attainable, not very spread out, and it looks like, see, the median is almost 10. This is actually kind of surprising, someone went above 10. That doesn't happen that often when you tell someone to list 10, but looks like someone did. Okay, so now I'm going to go back and look at that stuff on the on the density comparison. By the way, one big advantage of RStudio over just plain R is you can just arrow back and forth to see the different plots that you've done. That is much more difficult to do in the base R. And you actually can have a script window, or what they call a source window here in regular R, but yeah, it's a little more to it than what you do with RStudio, which is a big advantage of RStudio. Okay, so I'm going to go back now and save myself some typing. I'm going to get this stuff. I've already required the SM package, so I don't have to do that again. And give me some white space here. And so I'm going to put this in, and now I'm back there. Okay, so just a few options here. I'll show you. One of them would be LWD, which changes the width of the lines in here. And I'm going to put it to, let's say, 2. And we'll see what that does here. See how that kind of thickened the things up and make them, I think, a little bit easier to see. Now, another thing I'd like to do is get rid of that box. Now, in the SM package, it won't let you put frame plot equal false. I wish it did, but it doesn't. So, and actually, I just had to look this up earlier today to figure out how to do that. And I went to that Google thing, and I put margins, or I put frame plot SM package or something like that, and it took me about 5 minutes to find someone that had that showed you how to do it. And the way to do it is, before you get to that plot right there, PAR stands for graphing parameters, and again, I'm not sure what BTY stands for, but if you set it in quotations to in or no, it will take care of that. And again, now this differs from almost everything we will do in this SM package. You can't just put main equals and get a title there. You do that as a separate line. And the command is title main equal, and then in quotation marks, number listed by goal type, or whatever you want to put there. And you can do that \n thing as well if you want to. I'll do it just to show you. I can put that on 2 lines there. And so now I have a title and all of that kind of stuff. By the way, this density axis, I'm just going to tell you that for this class, you really don't need to worry about that, but you can just leave it there. I've tried taking it off before, and I end up then wishing I wanted it back in there, because it does tell me where to put text and that kind of thing. So I want to label these things here, and this does work just like it does with the base graph for box plots and that. So I'm going to find an X level, let's say of, I'm going to say 15, comma, 0.1. We'll just see how that works out for us. And then in quotations, I'm going to put challenging. And let's see how that comes out. I can just, I don't like that. I want it to go on the other side of the line. So let's maybe see where 16 will put us. Yeah, I had thought about going to 17, but oh well, I'll do it now. That's good enough. I actually might play with it a little bit more and move it off a little bit further, but that'll work. And then I might, for the attainable, I'm going to put, again, text, my X, I think maybe I'm going to put 12. And that one I'm going to put at 0.3. And then attainable. Not bad. And then finally for the last one, text. And this one I think I want to put around here somewhere. So I'm going to put maybe 2, comma, I think I'll put that at 0.25, comma, and then in parentheses, whatever text I want to have. Let's see, vague. That's not too bad, pretty good. So now I have a graph that I can export and go ahead and put into a document. And it has labels for each graph, and so you can easily look and see where those are at. I've got a title and all of that. So anyway, that'll be, I think, enough for this video.